Project name is Incident Trend Analysis and Predictive Ticket Prioritization. Project overview. This project is focused on automating ticket prioritization in IT support systems. Rather than assigning urgency levels manually, a machine learning model is used to predict the priority of a ticket. Step 1. Data generation. The first step in this project is to generate a data set that closely resembles real-world IT service desk tickets. Since actual support data is often confidential or unavailable, I use Python to simulate 2000 fake incident records. Now I'll walk you through the Python file which is responsible for creating the dataset used throughout this project. This script uses Python and the Pandas library to generate 2000 fake but realistic IT service tickets. Let me break it down. At the top, we import Pandas to create and manage the dataset, then random to randomly choose values for each incident's features. Then we create a dictionary called data with the following keys. First is ticket ID, which is a unique ID from 1 to 2000. Second is description, which is a short issue summary like incident related to network issue. The word after related to is randomly selected from common ID components like network, software, hardware, email, database. Third is impact. This shows how serious the issue is, either high, medium, or low. Fourth is category. This is the technical area the issue falls under, such as network, software, email, database. Fifth is priority. This is the predicted urgency of the issue from P1, which is very urgent, to P4, which is least urgent. Then the data set is saved to a file named indents.csv inside the data folder using to underscore CSV method. Before that, we are using the data frame class in which the dictionary is turned into a structured dataset with 2000 rows. Finally, a print statement tells us the file is successfully created. Now to generate the data, we will open the terminal and run the file. After that, the incidents.csv file will be created in the data folder and will be ready for use. So before running this file, I'll first remove the previous file. Let's remove these files as well. Here we can see that the file has been generated with 2000 records. Step 2. Data preprocessing. Second step of a project consists data preprocessing, which is a critical phase before training any machine learning model. Our dataset contains both textual data and categorical variables, so we need to convert them into a format the model can understand, specifically numeric format. Here's how it was handled. First is text features processed using TF-IDF. The description column contains free text like incident related to network issue. Since machine learning models cannot read plain text, a technique is used called as TF-IDF, which stands for term frequency inverse document frequency. This technique transforms the text into numerical values based on how important each word is across all tickets. It helps the model understand which words are more relevant to predicting the priority. Second is encoding categorical variables. Then I had to convert the other two columns, impact and category, which are categorical strings. For impact, values like high, medium, and low were encoded numerically. For example, high equals to 2, medium equals to 1, low equals to 0. For category, values like network, software, etc. were transformed using one hot encoding, turning each category into a separate country column. Third is combining all the features. Finally, we combined the TF-IDF vectorized text features with the encoded impact and category values to form a single feature matrix. This combined the matrix and is what we fed into the machine learning model to train it effectively on both the textual and categorical information. This pre-processing ensures that all features, whether text or labels, are now in a machine-readable numeric format, giving a model the right inputs to learn patterns and predict ticket priority accurately. Step 3. Model training. In this step, I trained a machine learning model to predict the priority level of each incident ticket, whether it's P1, P2, P3, or P4. Since there are four possible outcomes, this is a multi-class classification problem. I used logistic regression for training. While it's typically known for binary classification, Scikit-learn internally applies a one versus rest strategy, allowing it to work well with multiple classes. Logistic regression is chosen for three main reasons. Simplicity, it is easy to implement and understand. Speed, it is fast to train even with a large dataset. Explainability, it is useful in IT systems where transparent decisions are critical. After training and evaluating the model, it achieved approximately 80% accuracy on the test data. To assess performance, I also generated a classification report that includes precision, recall, and F1 score for each class. Now let's move to our code and take a look of the library used. Here, Pandas is used to load and handle our CSV data using data frames. Then we are importing the train test split function to split our data into a training set and a test set. Then we are importing logistic regression, which we will use to train our model. After that, we are importing TF-IDF vectorizer class to convert the ticket descriptions into numbers using TF-IDF. After that, we will import the classification report function to print a report showing how well the model is performing, like accuracy, precision, recall, etc. Then we are importing the job lib module, which will help us to save our model and vectorizers, so we don't need to retrain every time. After that, we are importing sparse to efficiently combine our sparse TF-IDF metrics with other features like impact and category. Then we are importing NumPy, which will help us to reshape our arrays during pre-processing. Then we are importing OS module to create a folder so we can save files there. After that, here we load our incident data file, which includes description, impact, category, and priority. Since ML models cannot understand text, so here TF-IDF is used to turn descriptions into meaningful numbers. Then these lines will turn labels like hi software P1 into numbers that a machine can understand. We then combine all the features, text plus impact plus category, into one big input matrix. And after that, we split the data in which 80% of the data is used for training and 20% is used to test how well the model performs. And here we are initializing the logistic regression model and train it using our training data. After that, with this line of code, we test the model using the test data and print performance metrics like accuracy, precision, recall, etc. Then these lines, we create a folder called models and save both the trained model and the TF-IDF transformer for later use. In the end, this line will confirm that everything worked and the training step is complete. Now let's run the file and verify whether files are getting created or not. So here we can verify that the files are created successfully and also the classification report has been generated successfully with all its values, precision, recall, weapon score, and support. Step 4. Web app with Streamlit. In step 4, we developed a web application within Streamlit to showcase how our machine learning model works in real time. This step focuses on making the model easily accessible and interactive for users. Let's move to our code now. Let's first see the libraries used. Here, Streamlit is used to create the web interface. Joblit is used to load the saved model and vectorizer. Sparse is needed to handle sparse matrix data. NumPy is used for array and matrix operations. Then this will load the trained logistic regression model, and the TF-IDF vectorizer from the saved files, so they can be used to make new predictions. And this will set the app's title at the top of the page. These lines of code will provide three key inputs: a description of the incident, its impact level, and the category of the issue. These inputs are used to simulate real-world ticket entries. Then, here, when the user clicks the Predict Priority button, the app performs these steps: transforms the description using the same TF-IDF vectorizer. It encodes the categorical values for impact and category. It converts them to numeric features using NumPy. Then it combines all features into one final output. After that, it makes the prediction using the model. And it displays the result using a reverse map. Now let's see how the app works. For this, we will run the app in the terminal using a code that is streamlit run app /app.py. So when the user opens the web app, they are presented with a simple form. The form asks the user to enter a short description of the issue. For example, incident related to software issue, the impact level, high, medium, or low. Let's take low. The category of the incident, like network, software, hardware, email, database. Let's take hardware. Once the user enters this information and clicks the Predict button, the app performs the following steps behind the scenes. It takes the description text and processes it using the TF-IDF vectorizer that we trained earlier. This converts the text into numbers. The impact and category values are also converted into numerical format using the same encoding we used during model training. All three features, the text, impact, and category, are then combined into a single input for the model. The input is passed to the trained logistic regression model then, which then predicts the ticket's priority level. It can be P1, P2, P3, or P4. Finally, the app displays the predicted priority level instantly on the screen. As we can see that it is P2. Step 5, Power BI dashboard. Now let's look at step 5, which helps us visualize the incident data from a business and operational point of view. The goal here is to make the data accessible to non-technical stakeholders like IT managers or support leads, so they can monitor trends and make decisions without needing to understand Python or machine learning. Now let's see the Power BI dashboard and visuals. So here are the visuals included in the dashboard. There is a bar chart which represents count of tickets by priority. Here it is showing how many tickets fall under each category: P1, P2, P3, P4. This gives a quick understanding of how workload is distributed by urgency. Then we have a stacked column chart, which is breaking down ticket count by category like software, hardware, email, database, and showing the priority levels within each category. This is helpful for identifying which areas are generating the most high priority tickets. Then we have a donut chart which represents count by impact. It shows how many tickets were labeled with high, medium, or low impact. This offers a visual balance of how severe most tickets are. Then we have slicers that allow the user to filter the entire dashboard based on priority level, impact, and category. These slicers make the dashboard more interactive, allowing users to dive into specific segments of data they are interested in. That was all in this project. I know there is scope for a lot of improvements, and I'm working on it. And thank you so much.